Hello guys, welcome back to STEM Trainers. Now in the previous video we have seen the two cases of area under the curve. One is where area is totally above the x-axis. Second is when area is some part of area is above the x-axis and some part is below. Then how do we solve those questions? Now today we are going to see how to find area between two curves. So I have taken a simple case where we have two curves fx and gx as you can see in the diagram. So they are intersecting, let's say at points A and B. So we need to find this shaded region that is between these two curves. So the formula for this is, let me first write the formula, then I will explain a little bit what's happening. So this formula will be integration of fx minus gx dx. Or sometimes we remember it like this also, integration of upper curve minus the lower curve dx. So this will be our area and the limits are from the smallest is A, next is B, so A to B, integration A to B. So this is my formula for finding area between two curves. Now, one thing I just want to explain, very simple is, not in very detail, is why is this our answer? You need to understand this, because if you don't understand this, then I have seen students make lot of mistakes in questions. So let me just tell you what's going on. So my fx is like this. This is my line x equal to A. This is my line x equal to B. This is my fx. So if I find this area that is between fx, x-axis and the lines x equal to A, x equal to B, then this area will be nothing but, this shaded area will be integration A to B fx dx. And similarly, if I have gx is something like this, and from x equal to A to B, if I find this area that is below the gx graph between x-axis, and then this area will be integration A to B gx dx, right? This is what we have done in case 1. So now if you subtract these two areas, so let me draw fx here also. Fx is something like this. So when you subtract these two areas, so basically what happens is you get this middle portion. Because fx is basically, if I call this as A1, if I call this area as A2, so basically fx is nothing but area 1 plus area 2. And this gx integration is nothing but area 1. And I need area 2. So that's why area A2 is nothing but integration fx minus gx dx. So that's just a basic explanation why we have formula like this, upper curve minus lower curve. And the explanation you need to understand, because if question is very simple, then you might get the answer using the formula directly. But in some cases, we will see in some examples that you have to think little bit. And for that, you must know what's the basic idea of integration and how this formula comes. Okay, so let's try some questions. First question is, find the area bounded by the curve y equal to 1 minus x into 3 plus x and y equal to x plus 3. Now y equal to x plus 3 is a line, and we know y equal to 1 minus x into 3 plus x is a quadratic, or you can say this graph will be a parabolic. And we know how to draw this, both the line and the quadratic. So first we will draw and see what area actually they are asking for. So let's quickly draw this. So my parabola roots. So y is 0, then what I am getting for parabola? X as 1 and minus 3. Okay. And it's a downward opening parabola because coefficient of x square is negative. So we have done this. When coefficient of x square is negative, it means sad phase. Sad phase means parabola is opening downwards. Okay, for the straight line, when x is 0, this is for the quadratic, this is for the line. When x is 0, y is 3. And when x is minus 3, my y is 0. Okay, so now I have these points, so I can quickly draw this. So parabola roots are minus 3 and 1. Okay, so minus 3 and 1. So something like this I have. This point is minus 3 comma 0. This point is 1 comma 0. Now the straight line. 0, 3 is actually this point, and minus 3, 0 is this. Now, okay, so this is the graph actually we are getting. And between these, it means this area is what we are looking for. And why it is 0 comma 3, we know in quadratic, if you substitute x as 0, we are getting y as 3. So they both are passing through 0 comma 3 and minus 3 comma 0. Okay, so now this is a very standard type of question. We need to find area between the two curves, and it is obviously above the x-axis also, so we can directly find this area will be upper curve minus lower curve, and the points are minus 3, x is minus 3 and 0. So my area is upper curve. Upper curve is, you can see, is the quadratic, and the lower curve is the line L. Okay, so upper curve is 1 minus x times 3 plus x minus the lower curve. Lower curve is y dx, x plus 3. So this dx. So let's find this. So integration. Now let's multiply this. First simplify this. So let's first simplify this expression little bit so that it's easy to integrate. So this will be nothing but 3 plus x minus 3x minus x square minus x minus 3 dx. And we can cancel this x, we can cancel this 3. So minus 3x minus x square dx. And let's integrate this. Integration of minus 3x will be minus 3x square by 2. And integration of x square will be x cube by 3. And now we have to substitute the limits, minus 3 to 0. So first we will substitute 0, in which case we will get 0 only. Then minus, we will substitute x as minus 3. So minus 3 by 2 into minus 3 square minus minus 3 cube over 3. So let's use the calculator, or if you can directly simplify, that's also fine. So what we will get here is 9 over 2. That is 4.5. So this will be our answer. So the area between this quadratic and the straight line is 4.5. So what are the important points when you are solving or finding area between two curves? First thing is, if diagram is not given, you first draw the curves. Then you shade the area, what area we need. And then you see whether it is between these two curves or not. This is important. So sometimes you will see it will not be between the curves. We will see some example. So after that, you just use the formula upper curve minus lower curve and then integrate. Okay, let's try one more question on this. Now, the second question is, the diagram shows a quadratic y equal to 2 minus 2x minus x square and the tangent to the curve at the point A, where it crosses the y-axis. Show that area shaded region given is 5 by 6. Okay, so we have to prove actually that this shaded area is 5 over 6. This is what we have to prove. Okay. So first you can see is sometimes in integration or area under the curve questions they involve differentiation also, or especially tangents and normals. That's very common, especially in exam questions. So okay, let's do this. So we have the diagram but we don't have the points. So first thing that we will need is what is point A. Now A is a point where the curve crosses the y-axis. So this is my curve y equal to 2 minus x square. And when it crosses y-axis, it means x is 0. Right? X is 0 at y-axis. So let's substitute x as 0. I'm getting y as 2. Okay, very good. Now we have point A, 0, 2. Next thing I will need is tangent at A. Okay. So I will have to find now the equation of tangent at 0, 2 for this curve. Okay, let's do this. So for tangent, we already have a point. So we will need slope of tangent. And we know dy by dx, that is derivative of y with respect to x, is nothing but gradient of tangent. So that is, let's differentiate this. We will get differentiation of 2 is 0, differentiation of x is 1, differentiation of x square is 2x. And we already know my x value is 0 because we are finding at the point A. So my gradient of tangent will be minus 1. Okay. So now I have the gradient. So now what I need is equation. So equation is y minus y1. Remember, equation of tangent is y minus y1 is equal to gradient into x minus x1. So let's substitute the coordinates. So y1 is 2, gradient is minus 1, x1 is 0. So let's simplify this, and what we are getting is y equals 2 minus x. So this is now the equation of tangent. So now you have the tangent. Okay. So if we have the tangent, then we can find, let's call this point where the tangent is crossing the x-axis. Let's call this point as B. And where the curve is crossing x-axis, let's call this point as C. And this, actually we don't need the point D, but okay, let's just mark it. Okay. So now I need point B and C. So for B point, at B, it's very easy to see because it is on x-axis. At B, y coordinate is 0. So if you substitute y as 0, then we get x as 2. So now we have the point B also, that is 2, 0. I need point C now also because that is part of the area. Okay, so let's find C. Again, at C point, because it is again on x-axis, y is 0 and C is on the curve, that is the quadratic. So y equal to, what's a quadratic? 2 minus x square. So let's solve this. So this is a quadratic. Let's make factors of this. So the factors of this will be x plus 2 into minus x plus 1. So this will be the factors. So from this I am getting x as minus 2 and 1. And obviously I don't need the minus 2 because that's point D. We need C, that is point 1. So this point is 1, 0. Okay, now that's a lot of work. So now basically we have everything that we need. We have point A, we have point B, we have point C. Okay, now we need to find this area. Now most of the students, what they do is generally, even if they got the coordinates, what they do is they just integrate upper curve minus lower curve. Upper curve is, in this case, is tangent, minus lower curve is the quadratic. But that will give you not this area. That's what we are looking for. That will give you something else. Okay, so don't do that. So that's why I told you that definition is important. Okay, let's see how do we find this area. Now first thing is, can we find this area that I'm shading with this green shaded area? This area is the area bounded by the curve that is quadratic and x-axis from 0 to 1. We can find this, right? So let's first find this area. So this area is nothing but, let's call this as E1. This is nothing but integration 0 to 1, the quadratic 2 minus x square dx. So this will come out to be, let's integrate this, 2x minus x square by 2 minus x cube by 3 from 0 to 1. Let's substitute the values. So you will get here 7 over 6. So now we have this green shaded area, but what we need is this orange area. So now you have to think, you can pause and think, how can we find this? Okay. So now what you will have to do is, you will have to find area of triangle AOB. Area of triangle AOB. Because if you have area of triangle AOB and you subtract this green shaded area, then you get this orange shaded area that we need. So this question is not that simple. If two curves are given, don't just think that you have to do upper curve minus lower curve. Okay? Because the other point, see, upper curve minus lower curve when you are doing, if you see at this question also, when the area starts with points of intersection of both the curves and ends with that also. Even you can see here also. This is the point of intersection and you have to find area between these 2 points. But here, the curves are only intersecting at one point. There is no other point. So upper curve minus lower curve will not give you the answer. Okay, so now area of triangle AOB, that is actually easy to see. This height is 2. This length is also 2. As you can see, the point B is 2, 0. So we can easily find the area of this, half base into height. So which will actually give me 2. So now the required area will be area of triangle, that is 2 minus 7 over 6, which is nothing but 5 over 6. So that is actually what we need to prove. Okay, 5 over 6. So these kind of questions are very important, and generally these are exam style questions, and generally they carry 10 to 12 marks at least. Okay, so that's it for this, and thanks for watching. If you have any doubts or any problems in this, you can just write it in the comments, and if you want any other specific topic or questions to be solved, you can just post it in the comments or you can email me. The email is given in the description. And thanks for watching STEM Trainers.